Hi everyone, this is Shankar, Assistant Professor, Department of Computer Science and Engineering. Today we are talking about class diagrams from OOAD. So in this topic, the following content actually we are going to cover under class diagram. Definition of class diagrams, what is the purpose of class diagram, what are the notations that we have used in class diagrams, attributes, visibility, association, and how we are applying the multiplicity, qualified association, aggregation, composition, generalization on the class diagrams, and association classes. So these are the topic we are going to cover under class diagram. Shall we go to start what is class diagrams? The definition for class diagram is a class diagram models is a static structure of a system, and the class diagram shows the relationship between classes, objects, attributes, and operations. Purpose of class diagram is to analyze and design of the static view of an application and describe responsibilities of a system, and it is the base, component, and deployment diagrams. So let us see what is the notation for class diagrams. So generally the class diagrams are represented in rectangular box, and this rectangular box is actually divided into three halves. The first rectangular part is actually shows the class names, and the second one is attributes and or properties, and the third part represents that the operations or member functions or methods that we can say is that. So generally we know that how we are declaring classes in programming language, whether it may be a C++ or Java, whatever it may be. So we know that the class has the class name and it has some set of properties and in its own operations, right? That actually we are represents in a diagrammatic way. If you consider a class, right, namely called student, the student may have the attributes called as name, roll number, section, right? For that, relevant methods we can use for display the student details or add some student to the given student database, or we can edit some information about the students, or we can delete the student information. So these are the methods we are defining inside the class, right? So for that, actually, we have drawn one student diagram, class diagram, right? So here, you just listen the cursor. Here, the first part already I said that it represents that this class name, right? So it is the name of the class. And second part of the class diagram is attributes. So here we have three attributes: name, roll number, and sections. Also here we have used some operators like plus, hash, and minus. So the plus represents that which are the attributes are preceded with plus, those are understood that these are all the public mode. The very attributes are declared as public mode. So which are the attributes are preceded with hash, we consider that these are all protected mode, and hyphen, it is private mode. So similarly, methods also the same. So we have used any operator. The meaning of the operator is if it is plus, it is public. If it is minus, it is private. If it is hash, it shows that protected. So the third part of the class diagram is operations or methods, right? So this diagram, this given example class diagram have four methods: display, add, edit, and delete. So similarly, for the same class diagram, we can draw object diagram also. The object is generally represents that the same way as the class. The only difference is we have to underline the class name. Then the diagram will consider as object diagram. Now the class name becomes object name. It will not be class. If the class name is underlined, then it will become an object. It is not a class. Then this all will become under object diagram. The next, we'll see what is attributes in the class diagram and what is the visibility mode in the class diagram. Right. So already we had we had discussed the attributes is a logical data value for the given object, and attributes are used to describe any object or concept or anything. For example, if you consider student, then the attributes of the students are obviously name, register number, address, and so on. Next topic is visibility. Visibility is actually marks to signify who can access the information contained within the class. If you have defined some attributes or method inside the class, what's the visibility of those attributes and methods for the class? That is actually visibility. So already I said, if the marker have plus, we can say that the attributes or methods are considered as public mode. If it is minus, private. If it is as, we can consider it as protected mode. If we have used tilde operator, it considered as packages, not members in attributes. The next, association. Association is a relationship between classes. It indicates some meaningful and interesting connection among the classes. For example, if you have two classes called register and sale, the association we can say is that records the current. It means that register is a class. It records the current sale from the class. Right? So it is an association. So it is a relationship among the two different classes. The next topic is multiplicity. Multiplicity represents that how many objects are connected. That is actually multiplicity. For example, if we have one object and another object, if both objects are connected, what is the way that are connected? That is actually multiplicity. The multiplicity can be written as an expression and it is specified at the end of the association link. For example, many example is given. For example, if we consider T, before the T, we have used in the link asterisk. It means that it may connect with zero object or more than zero object. It means that 0 or 1 or 2 and n number of objects. It represents that asterisk. The next you see one dot 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 asterisk is there. So one dot dot asterisk in the sense at least it should connect with one object and more number of objects, one or more. And next one dot dot 40, it means that exactly it should have 1 to 40. It should not have more than 40. Next one is 5. 5 in the sense it should connect only 5 objects. It's not less than 5. It's not greater than 5. So exactly 5 objects should connected with T. And next diagram shows that 3, 5, 8. It means that the T should connect with 3, 5, 8. So what is multiplicity? It means that it should represent how many objects are connected. That is actually multiplicity. The way how we are connecting is expressed in the given diagram. The next is qualified association. The qualified association has a qualifier which is used to select particular object from the set of object. For example, for the selection of particular product specification from product catalog, the qualifier will be item ID. For example, we just see the diagram A. The diagram A, it has product catalog. It contains one product catalog. That's why in product catalog, it has one. One product catalog contains one or more product specification. That's why it has one asterisk star. Sorry, one dot dot asterisk. Right. So one product catalog contains more than one product specification. It means that the product catalog can have at least one product specification. It may have 2, it may have 3, it may have 4 at n number of them. That's why we have specified here 1 at this end, 1 dot dot asterisk. And next, if the product catalog have item ID, we have searched with the item ID. So the qualifier is item ID. It contains multiplicity is reduced to 1 because one item ID should have only one product specification. In previous diagrams A, the product catalog we have not searched through item ID or anything else. Generally, we have a product catalog. That product catalog can have n number of product specification. But in second diagram, we have only one. We have one product catalog. In that catalog, we are searching one item ID. That one item ID can have only one product specification. That's why in the both the n can have only one. It is 1 to 1 connectivity. And the next one is aggregation. Aggregation is a specialization of association specifying a whole part relationship between two objects. The hollow diamond is used in arrow notation. Aggregation can occur when a class is a collection or container of other classes. The relationship between child and parent class is represented in aggregation relationship, where in child class can exist independently of the parent class. The example is given. The parent is car, passenger is child. So aggregation car may have passengers. They come and go. May have, may not have. That is actually aggregation. And next, composition. Composition is a special kind of aggregation which represents the whole part relationship. The solid diamond is used in arrow notation. So you should know the difference. The aggregation can have hollow diamond and the composition can have solid diamond is used in the arrow notation. And the relationship between child and parent class is represented in composition relationship where in child class cannot exist independently of the parent class. So here car can have engine. So every car has an engine. Without engine, we cannot can say the car. So in this situation, we can use composition. And next one is generalization. Generalization is the activity of identifying commonality among concepts and defining superclass. It means general concepts and subclass relationship. For example, if we have payment as a class, superclass, we have subclass called the payment can be done through cash, through credit, through check, and so on. Right? So we can consider in this scenario, the payment has superclass. It has more general concepts only. And we can have a subclasses called cash payment, credit payment, and check payment. So this is called as generalization. And next one is association class. Association class is an association that also has class properties. An association class is shown as a class symbol attached by a dashed dashed line to an association path. For example, if in a given diagram, we have a company and person, a company employs a person. The association class is employment, a salary. Means that a person may have employment with several companies. That is actually association class. An example is given. So initially we have a database. Name is actually identified with the help of integer number, and this database class can have store method. So you may have a doubt that how the name could become an integer, right? Because here we have the database can have many classes. So if it is 0, it can be identified with police. If it is 1, for example, right? Or if it is 1, it may identify with passport administrator. If it is 2, it may identify with applicant. And third, it may be regional administrator. So the database can have multiple classes, right? So here the name value is integer. So for here we have 4 classes. One is police, passport, regional administrator, and applicant. All 4 classes can have its own properties, own method. For example, if you consider police as a class, here the username is string type. Password is string type. It has the method called login, verify, and update. Similarly, all other 3 classes, passport administrator, regional administrator have the same method. Only the applicant can have somewhat different method called login, submit details, check status. Right? So these all classes can have connected with the databases. So such a way you have to draw the class diagrams. So whenever you are drawing the class diagram, you have to keep a point in your mind that it has to be 3 parts. First part will be a class name. Second part will be a properties. Third part will be a method names. Thank you guys for watching for this lecture series. Thank you. Thank you all.